But our next presenter is Johnny Casana with EDPR.
Hi, everybody. Thanks for the chance for being here. One more. We can move on. Before I get into specifically the wind and solar piece, I do like to, I get really excited about this stuff, and I like to throw up a picture of the U.S. at night, because I think it really illustrates in a real sort of gut and visual way the unique challenges that the West faces. You can almost see where the Western interconnect begins, based on just where those lights are, and how disparate and vast and sparsely populated our side of the country is compared to the dense, centers of industry that have already implemented these kind of system operators. Amanda? Good. Yeah. So there you are. You have the three different interconnects that are all one single machine. And I also like to throw up, I don't know if you can read those very well, but I throw up just the sort of raw numbers of how many states and the population and the nameplate capacity of these big system operators like MISO and SAP and TJM. They're roughly equivalent to the number of states that are in the Western Interconnect. The populations are similar, the nameplate capacities are in the same range, but all of these ISOs are able to do it with one balancing authority, one mind, one optimized IT system, and one set of communication standards. Whereas we have, like Amanda mentioned, 38, which is, gut check. Seems like we're doing something wrong. We're missing out. So these ISOs, they're saving money, increase grid efficiency, they reduce waste, enable wind and solar. And that's what I'm going to talk about a little bit now. So why does an ISO matter in the West for wind and solar? First thing is that utility scale wind and solar are cheaper than gas and coal. And I feel like I have to say this every chance I get, because it's relatively new. That wasn't true 5 years ago, it wasn't true 10 years ago. But it is true now, and I have some numbers up here from Lazard in terms of the levelized cost of energy. You can do the next slide. But it's not just about cheap electrons, and that's, of course, part of the problem. Wind and solar look and feel different than conventional thermal generation. A lot of the systems and standards that are set up to actually manage our grid and do the work of the grid have a hard time accounting for the abundant opportunity in low-cost, low-carbon wind and solar. And a broad regional grid is something that really helps realize that full value. And I have it right there on the right-hand side there, a sort of representation of that path control areas, which really isn't set up very well to benefit from the sharing like Amanda was describing. Go to the next slide. There's another study that Union of Concerned Scientists did about a year ago, which is really a great piece of work, looking specifically at when you change a system, 10%, 15%, it's mostly noise in the system, and the rest of that machine can keep picking up the slack for actually doing the work. But when you talk about a 50% renewable standard, you're changing out the shape and feel of the electricity for half or more of the energy in a grid. You actually need that energy to do the work of the system, provide the reliability and the ancillary services. And this is one of the real major challenges. And the study that UCS put out looks at comparing what the grid looks like in terms of cost and actual carbon output if you enable renewables to serve things like reliability and load following reserves, which are services that require some kind of a regional footprint or regional RSO, and compare that to plugging a lot of renewables in and then not changing how you source your reliability and just ramping up gas plants double or quadruple. And what they found was at those high levels, at the 50 or 60% penetration, it is much cheaper and more economic to have the renewables do the work as well as provide energy, not just plug in energy and ask the other 50% to do all of the work. move on. So beyond just cheap, one of the things that I always think about is that in the next 10 years, there's about 5.5 gigawatts of coal plants that are slated to retire. This is mainly because they're old machines from the 60s and 70s, and just like an old junker car, need to be replaced. And that means that the next decade or so is going to be a real important period of deciding what our grid is going to look like, and the decisions that we make in the next 10 years are going to have a pretty major impact on what our grid looks like for the next century. And in the absence of some kind of regional coordination from either the Mountain West or the proposal that Kaiso's put forward, or something else that resembles the functionality of those proposals, it will be very difficult to replace that amount of coal with anything except baseload natural gas. But in the context of a liquid fluid market, like you would have with a regional RSO, wind and solar, because they're so cheap and because they can provide those reliability services if you ask for them, become the clear winner from an economic perspective. And that leads to much less fuel price volatility, lower carbon impact, and also, and this is I think a real critical point, sets the electric grid up to be the baseline for decarbonizing other sectors like transportation and the built environment. And if you don't start with a clean grid, it's nearly impossible to get those sectors decarbonized to the degree that some states in the West have already set standards to try to achieve. Next slide. And the third major driver is California, and one of the reasons that matters a lot. And again, I like to think about scale when I think about these issues. California is over 60% of the Western Energy Coordinating Council in terms of load. It's a larger economy than France. It imports over 25% of its power. That's not a really commonly talked about statistic, but it's true and it's real. And what that means is that the choices that California makes have a big impact on its neighbors, because we have a Western interconnect grid that is, the wires are all connected, even if the operators aren't talking to each other. And these markets are interconnected. The consulting firm E3 has done a lot of work for the state in terms of analyzing how to achieve goals like the 50% RPS and the carbon targets that are set for 2030 and 2050. And one of the conclusions they've put forward is that in order to actually achieve the ambitious, aggressive carbon reduction targets in California, that state will need to do a litany of things, including getting about 60% of its energy from renewables. If you can move on to the next slide. And where does that come from? The path to 50 or 60% for California, if it's going to be done anywhere close to economic, always goes through working with its neighbors. Amanda mentioned this also. There have been studies demonstrating that, pairing that very high caliber wind in the mountain states with the California solar and Arizona solar makes both of those resources stronger and can save California customers about $1 billion or $1.5 billion per year, just because of the efficiencies that you get, because you don't have to build out as much transmission, because you don't need to buy as much fuel for running your resource adequacy reserves. These are the sorts of efficiencies and cost savings that really add up, that are really essential part of realizing the dreams that have already been put forward into law and statute in that state. And what that means is that in the context of a regional ISO or some sort of similar functionality, there's massive opportunity for economic development throughout the WEC. And that is the sort of opportunity that matters a lot to wind and solar developers, that I know from my work in rural communities matters a lot to those community members, and it's something that, you know, we're doing everything we can to see come to fruition. So, unlock the value of wind, lay the foundation for renewables, help replace coal, and help states meet their carbon and RPS goals economically. And get some steel in the ground while you're at it.